Good morning everyone. So today we'll be looking at chi-square tests and different types of chi-square tests. So specifically we'll be looking at the chi-square distribution and three different scenarios. With the first scenario, you're testing for the difference between two or more proportions, and that is when you use the test of proportions. When you are trying to determine whether two variables are related or independent, then you use the test of independence. And when you're trying to determine whether the frequencies of a distribution are the same as the hypothesized frequencies, you use the goodness of fit test. So there are three tests in total. It will be split into three different videos. And for our first video, we'll be looking at the test of proportions. So the question for difference between the test for the difference between two proportions state that a survey data in the table below represent the number of travelers using either the online or the airport check-in method in Brisbane and Sydney. At the 0.05 level of significance, is there a significant difference between Brisbane and Sydney in terms of the proportion of travelers who use online check-in? So as usual, we'll start off by writing out our null hypothesis, where we expect that the proportion of people who use online check-in in Brisbane is the same as that of Sydney. And the alternate hypothesis is that they are actually different. And so we also want our decision rule, whereby we will reject our H0 if our calculated chi-square is more than chi-square upper value. From here you can see that to work out my chi-square upper value, I need to know my level of significance, or the upper tail, which is 0.05, and we also want to know and to work out our degrees of freedom for a 2x2 contingency table, we'll be using 2 minus 1 multiplied by 2 minus 1, which gives us 1. So our degrees of freedom is 1, our upper tail area is 0.05, and that will correspond to a critical value of 3.841. So off the table, we know that the upper value for the chi-square is 3.841. So now we just need to work out what our chi-square is. So the first thing we want to work out is what our p-bar is. And p-bar in this case is used to estimate the population proportion of passengers in Brisbane and Sydney who will check in online. So 258 plus 375, that's the number of travelers checking in online, divided by 420 plus 530, that's total number of travelers, and that will give you 0.6663. That's for online check-in. And 1 minus p-bar would then be equals to 1 minus 0.6663 to give you 0.3336. This is airport check-in. And this too, right, will give you a total of 1, where p-bar plus 1 minus p-bar. So then this is the observed values, and now we can work out what our expected values are. And our expected values, we can use 0.6663 multiplied by total number of Brisbane passengers, likewise 3336. This is the expected values for Brisbane, and then you do the same for Sydney as well. and that's for Sydney. And now we'll look at a table where all of the expected values have been worked out for us. So over here you can kind of see that with the expected values, we have over here 0.6663 multiplied by 420, and this one over here was 0.6663 multiplied by 530. So the assumption for our chi-square test is that the expected frequencies have to be equals to or greater than 5. And the sum of all of this, and where this is equals to the observed minus the expected square divided by the expected. The sum of it all is equals to your chi-square value. So this is your chi-square value itself. So after all that tedious working, we figure out that our chi-square is actually 9.166. And since 9.166 is more than 3.841, we reject our H0. So our conclusion would be at the 5% level of significance, we have sufficient evidence to conclude that the proportion of travelers using online check-in is different for Sydney and Brisbane.